Mr. Watt, or whoever somehow came up on this video, welcome to my explanation of how wireless charging works. I have one as an example right here. It'll be used later in my video. So in modern day, it is very common to see and understand how wired charging may work, as it's pretty direct. It's directly transferred from an outlet or any power source directly to the device, and with the assistance of other components like a transformer to to reduce the volts going into your device, because you obviously don't want like a lot of power going straight into your device, because that's going to harm your battery. So there's other components like that that are all included into that. But as we all may understand how wired charging may work, that also sparks the idea of how does wireless charging work? Is it like Bluetooth, or does it just magically charge when placed upon a wireless charging device? Well, as cool as that may be, we have a different type of magic that I think you may be familiar with, as you may be a teacher of it. And it's called physics. To understand how uh, wireless charging works, we must understand what it is first. And firstly, the very basics. The idea of charging is transferring energy from a source to an electrical device. And secondly, wireless charging or wireless energy transfer, you could call it whatever, same meaning. It's technology that allows for electrical energy to be transferred from a power source, like an outlet, to an electrical device without the use of wires or physical connectors, hence the words wireless. This removal of physical connectors like wires and power cables allow for more convenience while delivering similar efficiency. Although there is a decline in efficiency, it's like quite noticeable. You do notice the how much more convenient it is, because if you see the back of my my computer setup, it is like tech hell. It's all a bunch of wires. Even inside my computer, it's not very pretty. But with the convenience of wireless, you'll remove that physical factor, and then it'll look more aesthetically pleasing and more minimalistic. With wireless charging, there are different ways to go about this topic, but there are two ways that are commonly seen in this topic, since they're very commonly used within chargers that many big companies and many chargers that even we use today. These two ways are inductive coupling and resonant inductive coupling. Those may sound like fancy words or just something that I'm just throwing at you, but inductive coupling is just the transferring of energy between two coils that are placed close to each other, following the principle of electromagnetic induction. That might have sounded like a lot, but the idea of electromagnetic induction is when a conductor, such as a wire right here, um, passes through a magnetic field and cuts through the field lines. It creates a current in the wire. Um, with that idea, resonant inductive coupling sounds different or sounds similar. It is similar since it's just an extension of inductive coupling. As an extension of inductive coupling, the main difference is that with resonant inductive coupling, it tunes the transmitter and receiver coils to the same resonant frequency, which allows for more efficient power transfer over a greater distance. I don't know the exact measurements, because it's really dependent on um, how strong your current is and the magnetic field is, but it is a noticeable change that you could see. So now that we understand what uh, this is, let me introduce you to the magic about wireless charging. So it starts with plugging the charging pad into a power source, such as an outlet, which is pretty obvious as you do need the power or electricity to flow in order to charge your phone. I think we all know that. You don't need to become a genius or NASA scientist to figure that out. So within the charging pad, show you right here. I can't show you the inside of it, but if you were to look inside of it, you will find a transmitter coil. And when electricity flows through this coil, it generates an electromagnetic field around it. Then you have the receiver coil, which is found in your phone or any device that you're using to charge, like phones, smartphones, etc. Anything that um, has a receiver coil for any device that has one will be compatible with this. Um, Not too sure on that actually, but they should work. Um, in the receiver coil, which is in your device, it contains the rectifier. A rectifier just converts AC current to DC current, which the device requires. Um, the primary purpose of the receiver coil is to do as the name suggests, to receive the energy from the electromagnetic field that was created by the transmitter coil. So now we have that idea, and we could focus on the more other parts of uh, wireless charging. And it's pretty important, but maybe overlooked. It's the alignment of the coils. Um, if these if these two aren't aligned, they're not going to charge. Similar to how if you have a basketball and there's no hoop, how are you going to score? If you have a hoop and you have the basketball, you could score. So with that idea in mind, you do need the two and two to align perfectly to have that connection for charging, or in our case, in our example, to make a shot in basketball. Um, where was I? Once the coils are close, they have to be close as well, because we have not. Well, in theory, if you were to have really big coils, and I could just think I'll talk about that later in the video. But once the coils are close and aligned, the electromagnetic field created by the transmitter coil creates a flow of electrical current in the receiver coil. This current can charge device's battery or power. So, as the electrical current flows into the battery's device, it charges it as if you were just plugging it in a charger with a cable, like just a regular thing. And that's essentially just how it works. Uh, the the coils, when they're all aligned, the electromagnetic field created by your transmitter coil, aka um, your charger, is creates a flow of electrical currents into the receiver coil, aka your device, and this current can charge device's battery or power as electrical current flows into it. So in summary, wireless charging or wireless power transfer, same thing, relies on using electromagnetic fields to transmit electrical energy from the charging pad, aka that transmitter, like the charger, to the device, the receiver, like your phone, without any physical connectors like wires. And this brings us convenience as we remove the need for physical connectors and um, minimize charging, I guess you could say, because modern day now, you'll get to notice how uh, you're getting to see a lot less wires because wires are pretty ugly, if I'm being honest. And yeah, so now that I'm coming to a close, I'm gonna just talk about the key features about wireless charging and challenges, and talk about how the future of wireless charging may be. So for the key components on wireless charging would be the power supply. You obviously need the power supply because without electricity, you you can't really charge your electrical device. Um, and secondly, you need your transmitter coil uh, because you need to generate an oscillating magnetic field to charge your phone. Well, it needs to pass on to the receiver coil, which brings me to my next point. You need the receiver coil, which is another key component, and the receiver coil just captures the magnetic field to create current. And the last key component is a rectifier, which converts the AC to DC to charge the battery. You needed to transfer AC to DC because that's what the device requires. I'm not too familiar with the exact reasoning because that's not what my SDS is about. So I would give you a better answer if I was studying why we need DC to charge batteries. So the challenges of wireless charging is efficiency. Gen Wireless charging is generally less efficient than wired charging, leading to longer charging times and wastes in energy, as it is only about 70% as efficient as wired charging, while the remaining gets just dispersed into air or transferred to heat. And that brings me to my next point. Heat generation can produce more heat, like noticeably more heat, nothing significant, but it's noticeable. And this may affect your battery health over time, which is not what we want. And another challenge is proper alignment. Um, with the MagSafes, which Apple sell, they do have like a small fix to this. So if you see it here, it magnetically connects to my phone. It'll just snap on. I don't know if you could notice it, but it's very faint and you will get that little snap there. And with that idea, you have the proper alignment, so that removes the risk of there not being a right connection with your basketball and hoop, in my metaphor, because you do need that. And future invocate in oh my gosh, future invocations is researchers are trying to extend the range and they're trying to work on technology that allows for charging a farther distance instead of just having it a direct contact. There's researchers trying to increase the efficiency. As we know, it's not efficient as wire charging, as that is more direct. And lastly is integration. We're trying to put this more into like everyday furniture, public spaces, but we're seeing this more common now with the cars as well. I know not sure what exactly the model is, but I know the Acura MDX, pretty recent, have has a wireless charger embedded into the car, and it works pretty perfect. No complaints from me. I mean, I don't really have it. I don't have a MDX, but my friend does, and it works well. So yeah, that's essentially the idea of wireless charging. Wireless charging is just transferring. It's not Bluetooth. It's not magic. It's physics. That's it.